Picture yourself curled up on the couch, flipping through an old family photo album. You have light skin. So do your parents. So do your grandparents. As you move from one generation to the next, almost nothing seems to change. It is easy to assume that the way we look has been fixed for a very long time. But each photograph captures only a tiny moment in a journey stretching back thousands of generations. And when we look at families around the world, the differences in human skin color can seem enormous. But here is where it gets interesting. Imagine that the album could keep expanding backward in time, beyond your grandparents, beyond every ancestor whose name your family remembers, and through thousands of generations before them. Eventually, you would discover something surprising. The distant ancestors of every living human had very dark skin. The entire human family tree traces back to ancient populations in Africa. At that time, there were no people we would recognize today as white-skinned. No matter how different we may look now, every human story began in the same place. That raises a strange question. If a dark-skinned person moved to a cold, cloudy region, would their skin slowly turn white? No. Their skin might become slightly lighter after spending less time in the sun, just as it might become darker after tanning. But those changes are temporary. The much larger shift from dark skin to light skin required thousands of years, countless generations, and real changes in DNA. So, what actually determines your skin color? And why did our ancestors need to change at all? To answer that, we first need to stop thinking of skin as nothing more than a wrapper around the body. Skin is the largest organ in the human body, and it performs dozens of jobs at the same time. It keeps water from escaping, blocks harmful microbes, and shields us from dangerous sunlight. Hidden inside it are tiny biological factories that constantly produce pigment particles called melanin. And those microscopic particles help determine where our ancestors could survive. Because the sun does more than provide warmth and light. It also sends invisible bursts of energy toward Earth called UV radiation. We cannot see them, but they can damage the strands of DNA inside our cells. As that damage builds up, it can sometimes lead to cancer. The problem is that UV radiation is not equally strong everywhere. Near the equator, especially across much of Africa, sunlight strikes the ground more directly. That makes UV radiation there some of the most intense on Earth. This is where melanin enters the story like a tiny superhero. It works like a natural sunscreen built directly into the skin. Melanin absorbs and blocks some UV radiation before it can damage our cells. The more melanin the skin contains, the darker it appears and the more protection it provides. For our ancestors living beneath the powerful African sun, dark skin was not a random feature. It was biological armor. Not exactly fashionable armor, perhaps, but extremely effective. But wait, cancer is only part of the story. UV radiation can also destroy something valuable circulating in the blood. Folate. Also known as vitamin B9. Folate plays an essential role in helping the body grow, repair itself, and function properly. When sunlight destroys too much of it, serious health problems can follow. So melanin-rich skin did more than protect the body's surface. It also acted like a shield, guarding the precious folate flowing underneath. And this is where the story becomes even more important. Folate is one of the key nutrients a baby needs to develop properly inside the womb. A mother's body requires enough folate to build the baby's nervous system. Without it, the child may be born with serious developmental problems. In other words, dark skin helped protect more than a single person. It helped protect humanity's ability to produce healthy future generations. Under the intense African sun, melanin was a bodyguard that never took a day off. That system worked well until roughly 100,000 years ago, when some human groups began leaving Africa. They had no airplanes, no maps, and certainly no navigation apps. They traveled on foot through the Middle East, into Europe, and across large parts of Asia. The farther north they went, the more unfamiliar the world became. Sunlight grew weaker. Winters lasted longer. Clouds covered the sky more often. The biological armor that had protected them in Africa was now entering a completely different environment. Then a strange problem appeared. The thick layer of melanin that had once been a major advantage began to work against them. Northern sunlight was already limited, and dark skin continued blocking much of the UV radiation that reached the body. Skin cannot stop and decide which rays are dangerous and which ones might be useful. It simply follows its old instructions. Block as much as possible. That was an excellent strategy in Africa, but it was far less effective in Europe. As a result, our ancestors began facing a serious nutritional crisis, and that crisis would eventually change the skin color of generations yet to be born. So what exactly was the body missing? Vitamin D, a remarkable nutrient the skin can produce when it is exposed to UVB radiation. Vitamin D works almost like a magnet, helping the intestines absorb calcium and use it to build strong bones. But in the north, sunlight was already weak, and melanin blocked even more of the limited UVB that remained. The biological armor that had once protected our ancestors from the sun was now preventing their bodies from receiving the light they needed. And the consequences were serious. Children who did not get enough vitamin D could develop rickets, a disease that softened their bones, bent their limbs, and weakened their bodies. In women, poor bone development could also produce a narrower pelvis, making childbirth far more dangerous. Think about that for a second. Skin color did not merely influence appearance. It could affect whether someone grew strong enough to survive and have children. Natural selection was beginning to change direction. Every human population contains small differences in DNA. By chance, some people carried mutations that caused their skin to produce less melanin. Lighter skin allowed UVB radiation to pass through more easily, helping the body make more vitamin D. These individuals were more likely to develop strong bones, and their children had a better chance of surviving. Over thousands of generations, those helpful mutations became increasingly common, gradually lightening the skin of northern populations. That might make it sound as though humans entered Europe and immediately turned pale. But evolution does not work like a photo filter. Ancient remains show that people lived in Europe for tens of thousands of years while still carrying genes associated with darker skin. That suggests the pressure from weak sunlight was not yet strong enough, or that people had found another way to survive without changing their skin color. One of the most famous examples is Cheddar Man, who lived in Britain about 10,000 years ago. When scientists analyzed his DNA, they concluded that he may have had dark skin and blue eyes. It sounds like a character created by pressing the randomize button, except it was entirely real. Cheddar Man lived in a cold, cloudy place, so why had his dark skin not become a serious disadvantage? The secret was on the menu. Hunter-gatherers at the time ate plenty of seafood, meat, and animal organs such as liver, all of which could provide vitamin D. Instead of relying entirely on sunlight to produce it through their skin, they obtained the nutrient directly from food. Their diet acted like a biological shortcut. It allowed them to remain healthy with darker skin, even beneath the gray skies of northern Europe. But everything changed during the Neolithic period, around 8,000 years ago. People began leaving the hunter-gatherer lifestyle behind. They settled in villages, raised crops, and depended more heavily on wheat, barley, and other grains. Agriculture made it possible to feed larger communities. But history has a habit of giving with one hand and quietly taking something away with the other. The problem was that grains contained very little vitamin D. As fish and meat became less important in the diet, the body had to rely more heavily on sunlight. Dark-skinned people had greater difficulty producing enough vitamin D, especially during long northern winters. At that point, lighter skin was no longer a minor advantage. It became a powerful way to capture every available ray of UVB and protect bone growth, general health, and reproductive success. Over time, researchers identified several important genetic switches involved in this change. A variant of the gene SLC24A5 helped reduce melanin production, while variants of SLC45A2 contributed to even lighter pigmentation. These genetic changes spread because the people carrying them had an advantage in environments with weak sunlight and limited dietary vitamin D. Within only a few thousand years, the appearance of many European populations changed dramatically. By evolutionary standards, that was remarkably fast. But wait, Europeans were not the only people to evolve lighter skin. Many East Asian populations also developed lighter pigmentation, but they did so through a partly different set of genetic changes, including variants connected to OCA2. Two distant regions faced similar environmental pressures and arrived at similar results through different biological pathways. Scientists call this convergent evolution. Nature encounters the same problem and discovers more than one solution. Evolution, after all, has never followed a single blueprint. Skin color was not the only thing changing when humans began to farm. A quieter transformation was taking place inside the skeleton. Hunter-gatherers had spent their lives running, climbing, carrying heavy loads, and moving almost constantly. Once people settled into villages, that level of physical activity declined, and bone density gradually decreased. Weaker bones made vitamin D even more important because the body needed it to absorb calcium. As a result, the evolutionary pressure favoring lighter skin became even stronger. Here is where things get strange. One hypothesis suggests that lighter skin may have been a side effect of humans gradually domesticating themselves. Domesticated animals often become calmer, develop smaller bones, and sometimes grow patches of white fur. Some researchers have proposed that stable community life may also have affected neural crest cells, which are involved in the development of both bones and pigmentation. At first, it sounds like a coincidence. Then you notice how many of these changes appeared together. But our ancestors did not simply wait for evolution to solve every problem. They found a cultural shortcut: drinking animal milk. Most mammals lose the ability to digest lactose after infancy, and early humans were no exception. Then certain populations developed mutations that allowed adults to keep drinking milk without becoming sick. Milk provided plenty of calcium, helping support bones in cold northern regions. Because sometimes the human solution to a biological problem begins by staring at a cow and wondering, can we drink that? And that was only part of the story. While skin pigmentation was changing, new variations in eye color were also beginning to appear. Blue eyes may seem ordinary today, but they are relatively new in human history. Around 10,000 years ago, most people still had brown eyes. Then a mutation that reduced melanin in the iris appeared near the Black Sea region, turning brown eyes blue. Here is the surprising part. People with blue eyes today may all have inherited that trait from the same distant ancestor. In other words, millions of strangers around the world could be extremely distant relatives without ever realizing it. The mutation may have spread partly because the unusual eye color attracted potential partners. Natural selection helps you survive. Sexual selection sometimes simply says, "Those eyes look interesting." So what is skin color, really? Imagine it as a biological light meter, constantly trying to keep the body in balance. Skin must be dark enough to protect folate and DNA from UV radiation, but light enough to produce sufficient vitamin D. The body does not care which color looks more attractive. It is simply searching for the amount of melanin that gives you the best chance to survive, reproduce, and pass your DNA to the next generation. But wait, if weak sunlight pushed human populations toward lighter skin, why do Inuit people in the Arctic still have relatively dark pigmentation? In theory, extremely light skin should help them capture more of the region's limited sunlight. Once again, the answer lies in food. Fish and marine animals provide abundant vitamin D, reducing the need to produce large amounts through the skin. At the same time, melanin still offers protection from intense sunlight reflected off snow and ice. The Inuit example shows that skin color is never controlled by a single factor. Sunlight, diet, lifestyle, and DNA all work together. When one part of the system changes, another can compensate. Across thousands of generations, the human body makes countless tiny adjustments. No one wakes up one morning with a completely different skin color. Evolution moves slowly, but the results can eventually become impossible to miss. Today, the story has entered a new chapter. We have sunscreen to reduce the damage caused by UV radiation and vitamin D supplements for people living in places with limited sunlight. We also have clothing, heated homes, global food supplies, and modern medicine. Culture and technology now allow people to live far from the environments their ancestors adapted to. Human evolution has not stopped, but we have begun changing the rules of the game. Yet no matter how advanced our technology becomes, skin color remains a genetic diary written across the body. It records the journey our ancestors took out of Africa, across deserts, grasslands, mountains, and frozen landscapes. Every shade carries traces of the sunlight, food, and challenges they encountered along the way. So when you look at someone's skin color, you are seeing more than an outward feature. You are seeing one small chapter in humanity's extraordinary history of migration. But that genetic diary teaches us something important. No skin color is better than another. Dark skin and light skin are simply different biological toolkits, shaped for different environments. Very light skin exposed to intense sunlight without protection is more vulnerable to UV damage. Very dark skin in a region with little sunlight may have more difficulty producing enough vitamin D. Nature does not rank people. It asks only one question: which body is better suited to survive here? Human history, however, has often forgotten that simple truth. Skin color has been used to divide people, judge them, and justify unfair treatment. Science tells a completely different story. Beneath the thin surface of the skin, all humans share nearly the same genetic code and trace their ancestry back to common populations in Africa. The differences our eyes notice are mostly small adjustments near the surface. Think about that for a second. Humans created enormous divisions over different amounts of melanin. And that is what makes the journey from dark skin to light skin one of the most remarkable transformations in the history of life. Our ancestors had no idea what vitamin D, folate, or SLC24A5 were. They were simply trying to find food, stay warm, raise children, and survive another day. Yet with every generation, DNA quietly recorded the pressures of the surrounding environment. Your body still carries traces of sun-scorched landscapes, cold forests, and frozen grasslands crossed by people long ago. But here is the part worth thinking about. Mutations that produced lighter or darker skin did not appear because nature was trying to create beauty. They appeared randomly, and the environment determined whether they were useful. People whose traits suited their surroundings had a better chance of surviving and passing their DNA to their children. Our existence today is therefore the result of a negotiation with the sun that lasted hundreds of thousands of years. And our ancestors never got to read the terms in advance. So the next time you stand in front of a mirror, try looking at your skin differently. It is more than a color or a feature of your appearance. It is a living biological system that responds to light, protects DNA, preserves folate, and helps the body produce vitamin D. It carries clues about where your ancestors lived, what they ate, and which challenges they survived. What you see in the mirror is not just skin. It is a piece of history that is still alive. Step back far enough, and the world begins to look like an enormous palette. Near the equator, human populations developed more melanin to defend against intense UV radiation. Farther north, many populations evolved lighter skin to make better use of weaker sunlight. In places such as the Arctic, diet changed the equation again. Every shade has its own history. Human diversity does not mean we belong to different species. It shows how one species found countless ways to adapt, and the story is still far from finished. Researchers continue to identify genes connected to skin pigmentation, eye color, and adaptation to different environments. DNA recovered from ancient bones may overturn ideas that once seemed certain. A skeleton uncovered today could reveal that people living thousands of years ago looked nothing like we imagined. History has a habit of doing that. It waits until we feel confident, then places a new piece of evidence on the table. Evolution is also continuing right now, even if it moves too slowly for us to notice. The ways people eat, migrate, choose partners, and settle in new environments may continue changing the frequency of certain genes in future generations. At the same time, sunscreen, supplements, clothing, shelter, and modern medicine have weakened many of the natural pressures that shaped our ancestors. Human evolution has not stopped, but culture is increasingly helping DNA write the next chapter. In the end, skin color is not a boundary dividing humanity into different ranks. It is a collection of answers our ancestors developed in response to the same question. How do you survive beneath the light of the sun? Where that light was intense, the body produced more melanin. Where it was weak, populations often evolved less melanin to capture more UVB. Whether our skin is light or dark, we all stand beneath the same star and depend on the same source of energy. In that sense, we are all children of light and descendants of extraordinary travelers. The skin you carry is a message written in DNA and passed through countless generations from the distant past to the present. It reminds us that our ancestors moved, adapted, and survived so that we could be here today. And perhaps that is the most beautiful part of the story. Our different skin colors are not walls separating humanity. They are different chapters in the same evolutionary journey.